Okay, so hello everyone. Today we're going to be covering RobotC, and we're going to be going over movement and programming basics. So to start out, everyone click new file, and we're going to be met with this task main method. So two important things to remember whenever using a robot virtual world, which is what we're going to be using today, is you need to first have robots set up for the compiler target as virtual worlds, since we're not going to be running any of this code through a physical robot. And next thing to do is, and something that's essential for any code, any RobotC program, is we need to have a specific configuration. So in this case, it's called a progma, and all a progma does is it basically tells RobotC which motors we're using and where, like what ports they're going to be in, so we can basically send information to them. So we're going to say progma config standard model and we're going to be using the square bot today. Compile program. Sorry, no space between standard and model. Okay, so now no issues. So once we've compiled this, if we go to motor and sensor setup, we'll see that it's automatically assigned all of our motor and sensor setup. So right motor is of X393, encoder port is I2C, right? All of that information is put in. So now what we can do is we can get to coding. So first, let's make our robot go forward for 3 seconds, right? Just a simple, basically hello world kind of program. So we're going to say motor, square bracket, and we're going to say and left motor and right motor. So these are just variable names that are assigned in the motor and sensor setup. So it's important you get the capitalization and everything correct. Right, and then capital M motor. And we're going to set the power to 127. And 127 is the max power for these motors. So it's going to basically accelerate from 0 to 127 for 3 seconds in our case. So I'm going to say wait 1 millisecond and then 3000, because 3000 milliseconds is 3 seconds. And you know what, at the beginning, let's just say wait 1 sec, and let's just say 1000. Okay, so now that we have this code, compile it, everything seems to be fine. Now let's go to compile and download program, and this will open up the robot virtual world. Let's go to movement, and let's just do the driving straight activity. So when we run our code, it should wait for 1 second and then go for 3 seconds. 1, and then 1, 2, 3, and it stops, right? So yeah, so our code is successful. That's doing what we asked every single time. Okay, yeah, so that is the first step of mastering movement basics. Okay, so now that we've finished something basic, let's do something a little more challenging and fun. Let's make our robot do a basketball drill. So one of the applications on the robot world is they have little tasks. So if we click compile and we go to basketball drill, we can see this little drill that they have set up, in which we can basically earn a completion achievement. So the goal of this challenge is to go, touch the line, come back, go all the way to the second line, touch it, come back, and go all the way to the third line, touch it, and come back. So this is basically a suicide drill, right, that we do in basketball. So we're going to make our robot do this. So let's start the activity, and let's just get a gauge for what we want to do. So right now it's running on the same code as before, so it's going for 3 seconds. And obviously we're saying 3 seconds is a little too long, so when we're going to program it, let's make it 2 seconds. So start a new file, and we can just copy and paste all this stuff from before, and we'll make a couple iterations and changes. So we still continue to have this progma configuration, right? And we can basically say that instead of 3 seconds, it's going to go forward for 2 seconds. And next thing that we're going to do is we're going to make it take a point turn, and come all the way back. So in order to do a point turn, one motor needs to go full speed, or go at a certain speed in one direction, and the other motor will go at the exact same speed in the opposite direction. So basically we're going to make this go 127 right motor, or let's make it so that the left motor, let's turn right. So we'll say the left motor is going to go 127, and we'll say the right motor will go negative 127. So it's going to go full power the opposite direction. And what I found is for it to turn exactly at or close to 180 degrees, it's going to have to turn for 1250 milliseconds. So it's like 1.25 seconds, right? It's not exact, but it's pretty close, so it's something that we can work with. So now if we run this and if we compile the program, let's save this as, we'll call it basketball basic test. Save. And if I go to robot, compile and download program, it's going to open up. Movement, and we'll do the basketball drill. So if we run our code, it's going to wait for a second, go forward for 2 seconds, and then make a point turn. It's close to 180. And it makes a point turn. So it's facing back. So now we're going to want to repeat this activity. And anything in which we're repeating or looping, we're going to have to use loops. So in this case, let's use a while loop. And let's just make this while loop go on for infinity. Or so in order to make a while loop go on for infinity, we're going to need to have basically a statement that holds true forever. So in my case, I'm just going to say 1 is greater than 0, right? Nothing can dispute that. So it's going to run forever. As long as 1 is greater than 0, this code is going to run. So that's going to be forever. So I'm just going to compile and download this program. And let's just test that out. See what happens. Start activity, run, waits 1 second, goes, turns around, it's going to come back, turns on. So obviously what's going to happen is this robot will just stay in this place, as it's not really going, and it says incomplete challenge. It's not following the drill. It's not going to the second line. So what we want to do is we want it to increase, or for the duration, we want the duration that the robot goes forward to increase every time it comes back. So one thing that we can do is we can use a variable. So let's make an int counter, and let's set this to 0 to start out. And we'll say that this counter will basically add to the time. So we'll say counter times, and we'll say 1,000. It will add 1,000 seconds for each iteration. And we'll make the counter incrementally increase. So counter is equal to counter plus 1. So now what this code should do, or I'll just test it so we can all see. No issues with the code. Movement, and let's start. It's going to go, turn around, come back, turn around, go all the way to the second line. Hopefully 1000 was enough. Yep, just makes it. It's going to come back to the start. Should turn again and go all the way to the last line. And yep, I think it's going to make it. And it should come all the way back. Nice. Yeah, so success. So we've completed this basketball drill. So I'll let you see the code again. It's pretty simple. Well, this while loop will still run for forever, but obviously it's being stopped by the virtual machine. So we're waiting a second, then counter set to 0, and we start this while loop and we say this motor, it's gonna go full power for 2000 plus counter times 0. So in this first iteration, obviously counter is gonna be 0, so it's just gonna go forward for 2000 seconds. Then it turns and it's gonna come back for 3000 seconds. Then it's gonna turn and go again for 4000, then 5000, then 6000, then 7000. So it's always going to be adding, and it's going to go farther each time. Yep, so that concludes our first lesson for RobotC tutorials, and yep, okay, thank you.